Hello guys, this is Viera from Viera Manufacturing Services. Welcome back to my feed tutorial. So in the last tutorial we successfully designed the VMS Project 2. So in this tutorial we are going to be generating the M&G code. Let's get started guys. So firstly, looking at the part anyone could deduce, we are going to be using a mailing operation, right? Mailing system. So one thing, just common solid cam 2.5D, new mailing. Okay, yeah, save project, definitely. So this is VMS Project 2. Sorry, Project 2. Okay, I'm good with this name. You can use your own name. Okay, fine. Okay, perfect. Okay, so as explained last time, external simply means that the cam feature will be totally separate from your cat features, as we explained in the previous video. So internal, it simply means that the cam features are going to be embedded into your cat, or let's say solid cat 3 folder. Okay guys, so let me just take external. Let me check something. External, so making sure that your unit is in inch because the part was being designed in inch. Okay, so I'm taking internal. Okay, so next thing, we need to define the coordinate system. So firstly guys, you could define the CNC machine controller. So by default I'm using Gmelin 3X, so definitely you could change your own controller. So let's go for coordinate stock. Okay, so let's select surface. Okay, definitely you could just choose maybe this top surface, could be good. Okay, perfect. Making sure your X is perpendicular to the Z, making sure that the Z always look upward. Okay guys, so I think this is good. So okay, take some time. Okay, we are good to go. So next, stock definition. So clearly I'm going to be using, thinking about the raw material or the workpiece to use in real life. We are going to be taking a rectangular raw material. So in this case, no need to use cylinder. We go directly for box, absolute coordinate, and take model dimension. Perfect. Okay, good. Target, it's selected by default. You could just click target, just on select all, and then select the cat model. Okay, good. So we are good to go. Okay, so you could equally edit program number. So this is program number 2. Okay, all good. This is for iMachinery. Okay, perfect. So guys, the first operation I'm gonna perform here is facing operation. So let's go for facing. Okay, coordinate system remains same. Tool, as we spoke last time, the tool used for facing operation is a face mill. Face mill selected, swap to inch. Let me just swap this. Yeah, okay, to inch, good. So using inch of 2 inch, good. Okay, one thing, making sure the length, let's take length of 5. Okay, my tool holder is already activated. So in case your tool holder isn't activated, just come over here, view, settings, and then auto add tool holder and adapter. So this should be ticked. Okay, fine. Exit. Okay, good. So you have a tool holder, making sure the coolant should be on. Okay, all good. Levels, so upper level, you know, this point at 0. Lower level, so the facing should be too deep, so let's take 0.001, just enough. Step down, maximum step down 0.04. Technology, hash 50%. Remember, for rectangular raw material we use hash. If the raw material is cylindrical, then use quantum. Okay, complete in Z level. Or fine, link, none, control. Okay, or fine, save, calculate. Okay, simulate, solid, verify. Okay, let me just slow down the speed, play. Okay, just perfect. Okay, good, just perfect. Okay, let me just slow down up to the last level. Okay, just perfect. It's very fast. Okay, good. Okay, just close this. So the next thing we are going to be speaking about is, just a moment, you know, simulate. Good. Raw material or rest material. So you notice that the facing has been done, right? So right now we are left with this pocket, and then we have to, you know, to machine the external part, right? The external portion of the part. So when we machine external portion of the part, that one is referred to as profile operation. So we have, you know, two pocket operation and equally a profile operation. Let's get started rapidly. Okay, pocket. Okay, good. So this is the pocket over here, so I'm going to select this. Good. And again I select this pocket. Fine. Okay, I think all fine. So tool. So for pocket operation we are going to be using an end mill. Click on end mill. Let's take a more bigger end mill. Let's try 0.5. okay, making sure the length should be, you know, 5. Holder activated. Fine. Okay, coolant on. Okay, it's all fine. Levels, upper level at this point, lower level, sorry, pocket depth at this point. Okay, fine. Okay, step down 0. Let me take 0.054, sorry. Okay, nice. Technology. Okay, I'm going to be using roughing operation first, then I do a proper finishing. So 0.0, let's take 3. Let me just go deep, then floor finish, and then, you know, floor finish, wall finish. Okay, fine. Number of passes 1. Good. Quantum. Oh, fine. Good. Link, none. Again, this is a pocket operation, so I will take normal. I'm going to be taking length 0.01, same as slit art. No, this is none, right? It's when we are using profile operation that we do this. So motion controller, parameters, fine. Save, calculate, simulate, so to verify. Let's do this. Okay, let's add speed. Okay, all going fine. Okay, good. Rest material. Oh, it's not properly done. Still have some surface over here. Okay, we still have some surface. Okay, let's just go back. Levels. Okay, all seems good. Technology. All seems good. Okay, let's check on this. Let's just modify the tool. Let's look at the tool too. Okay, let's take a tool, a smaller tool, 0.25. Okay, save, calculate, simulate, play. Okay, rest material. Okay, up to now not good. Okay, anyway, let's advance. We are going to be seeing what's the issue over here. Maybe we can use the data value to go more deep, but it's fine. Okay, so next thing what I'm gonna be doing is the pocket operation, guys. Pocket operation. So click on profile. You have to machine the answer pipe. So okay, over here, then this part selected. Okay, as you notice, good. Tool and end mill. I'll take another end mill, making sure this should be 0.5. Good. And then the length of 5. Okay, levels upper at 0, lower level over here. Then I'm gonna be using a data of -0.1. Fine. Technology, making sure the tool looks outward. So right now it's looking inside, so flip it to right. Okay, perfect. Okay, step down, roughing. So making sure this is 0.0, let's say 2, 0.002. Sorry for this, 0.02. Good, fine. Maximum step down 0.04. Extension of 10 and then 0.04. Okay, all good. I think we are good to go. Link normal 0.005 or lesser one. Semi select R. Okay, or fine. Save calculate. Let's simulate. Okay, let's see. Okay, good. Rest material. Okay, all fine. Okay, so next thing we are going to be looking at this hose. Okay, let's look at the hose. So last time, guys, let's just untick this. So last time I showed you guys how to how to make hose using drain operation. Okay, so today I'm gonna be showing you guys how to make hose using what we call a hole operation or hole wizard, right? So just come over here, this little extension, you will see hole over here. Oh, if you can't see this, just come over solid cam AFRM, right, and just click hose, hole wizard process. Okay, making sure automatic coordinate is selected, making it equally sure that wizard is selected. Then just come over here, just select this part. Okay, it's going to select all the holes automatically, and then it's going to machine the holes for you. So okay, sometimes this particular hole wizard makes some errors, but hoping it will make some errors over here. Okay, let's just simulate this. Solid verify, play. Okay, let's take OS material. Okay, perfect, no mistake, extremely perfect, good, all fine. So just by using hole wizard, you could just create a hole simply that way. So anyway, in the next tutorial, guys, I'm gonna be showing you guys how we could still machine this hole using basic drilling operation. Okay, so but this video, this hole wizard is just perfect. So guys, you notice that we have these lines over here. So these are actually the chamfers, right? And the various fillets. So how can we machine this? Okay, so now I'm gonna introduce you guys to another operation. Now you should understand that there are two ways of making, or let's say there are two ways to machine a chamfer. One, using profile operation. Two, using what we call edge debugging recognition, right? So but in this tutorial we are going to be using edge debugging recognition. So let's click on edge debugging. Okay, just by selecting, just new. Okay, so face, making sure selection mode should be body. Why? Let's just take face, guys. Take face. Now select this face. Okay, good. Over this face, good. And then this face. Oh, fine. So it's going to machine the chamfers within this face, right? Okay, so let's look at this. Okay, tool. So for chamfer, we use a chamfer tool. So making sure you're over here, just scroll down. So we have chamfer mill. Okay, I'm good with this. I'm just gonna increase the length, let's say 5. Okay, good. Okay, fine. It's okay. Okay, making sure coolant on. Okay, perfect. Okay, levels. Now let's take just not that much, 0.0, let's say 1. Let's try this first. Okay, okay, 0.01 is fine. Okay, technology. Okay, this perfect already. 0.5, just put 1 equally. Let's go more down. Step down of 0.04 equals step down. Okay, all fine. Link. Okay, it's all fine. So just take normal, making sure it's 0.01. Okay, same as slit art. Okay, all fine. Save calculate. Let's look at this. So they verify. Okay, let me just slow down your speed. Play. Okay, beautifully done. As you notice, the chamfer is beautifully done. So if you feel like, you know, your chamfer size is big or too small, you could, you know, just play with the data over there. Okay, rest material. Okay, perfectly done. You see that red mask goes away. So I feel like my chamfer is perfect. Otherwise, guys, you know, you come over here, you play with the chamfer depth, and equally make sure you play with the cutting diameter. Okay, guys. Okay, good. So just click over here, simulate, rest material. Let's look what is left. Okay, so looking at this, chamfer has been done. We have a chamfer over here, back side. Okay, so guys, one thing we are going to be doing right now, it's we are going to define new coordinate system for this particular portion, this particular direction, you know, for each site, so that we can use edge debugging recognition in order to make a chamfer. And I think it's going to be okay. The part is going to be fully machined. So let's do this. So over here, coordinate system, double click. Okay, add coordinate system. So we're adding new offset. Okay, let's rotate this. Let's be fast a little bit. Select surface. Okay, all good. Okay. Okay, fine. Okay, it's taking some time. Perfect. So one thing I'm going to be doing is, you know, this is actually debugging surface. Just edit. Okay, so we are going to use save copy. Yeah, click on save copy. Okay, making sure that this becomes Mark II. And again, you know, the tool is already mentioned, levels are equally mentioned, so all mentioned totally. Technology, we are just checking. Okay, all fine. Link, all good. I think it's all good. Just save calculate. No geometry selected. Okay, good. Geometry, just come over here, new, click on new. Surface should be selected and click on the surface. Okay, perfect. Okay, save calculate. Okay, so as you notice, guys, it comes over here, right? Perfect. So one thing, simulate. So verify. Okay, good. Rest material. So good. As you notice, all is forming itself. So let's speak now about this particular direction, so cancel this. Again, shift this, coordinate system, open, add, so select face, over here select this face, okay, all fine, okay.
Bravo.
So what's next is just click OK. Okay, good. Oh, it takes a lot of time. Okay, so it's debugging, making sure Mark 3 should be selected, then tell the machine where exactly the fillet or the chamfer is. So it's surface, add the surface. Okay, it's fine. Okay, I think it's fine, right? Okay, let's check this. Then, you know, tools. Okay, one thing I make a mistake, like, anyway, we'll just redefine it, you know. So select. Let's just be fast, chamfer. Okay, just edit length. Okay, okay. Making sure the coolant should be on. Perfect. Levels, I'm taking 0.01. Okay, technology, just put one over here. Step down, 0.04. Okay, I'm all fine over here. Let's check. Okay, good. Link, normal, 0.01. Same as link in, all fine. Okay, I think we are good to go. Save, calculate. Okay, simulate. Let's look if this will be sufficient. Okay, play. Okay, chamfer done. Rest material. Perfect, just perfect. As you notice, it's removing those marks. It's actually removing these marks. Okay, guys. So now we are going to talk about. But one thing is, it removed this one, but this isn't removed. Okay, so we have to see about that too. Okay, let me just check this. Show the size is affected and equality size is affected. Okay, so we'll see about that later, guys. So let's deal about this side first. Okay, so same thing, coordinate system. Okay, fine. Open, add. Okay, surface, this surface. Okay, okay, just take some time. Okay, I think it's done. Okay, okay, good. Edge debugging selected, making sure coordinate 4 or mark 4, then surface, this surface. Okay, levels. Oh, we have again. I just forgot to save and copy. So chamfer. I'll go a little bit fast, guys. 5. Okay. So just recopy what we did recently. Save, calculate, simulate, still verify. Perfect, rest material. Okay, this is done. Perfect. So as you notice, it's totally done, guys. It's totally done. Okay. Okay, so no red material indicates that the part is fully machined. So guys, Next thing we are going to be doing is, generating the M&G codes for this part in our Simco editor. So just close this. Okay, just come over here, operation, G codes. Let me just take, G code, all, generate. Oh, my software has a breakdown. Okay, hope all is going to be fine. Okay, perfect, guys. So guys, this is the M&G code for VMS Project 2. Okay, so let me just do one thing. Let me save this. Okay, just by coming over here, click on simulate. Then guys, come over machine simulation. Not responding. Let's try one more time. Okay, then just come operation, rather come under SolidCam simulator. Okay, so this equally, another way actually to simulate your project. Yeah, so it's another interface. So I'm showing you guys the various interface. So this is another interface to make your simulation. Okay, hope you enjoyed this, guys. So with this, guys, and upon having the M&G code, we can actually say that we are pretty successful with the VMS Project 2. So guys, meet you guys for the next tutorial. In the next tutorial, guys, we are going to be designing the VMS Project 3. Okay guys, thank you so much. Kindly share, like and subscribe the video. Thanks guys.